In the last video, I finished it having created 3 static methods on the base class that pretty much did the same thing as the instance methods. I called these static methods using instance references in my main method. What I mean by that is I called these static methods using variable references and not the specific class names, as is usual when calling static methods. IntelliJ is trying to get my attention by highlighting each of these. This code ran and executed fine. I'll run it again now. The last 3 segments in the output are the results from executing those static methods using the variable references. Because these static methods are declared only on base class right now, all 3 segments have the same output. What I'll do next is open up the base class and copy the entire public static method called recommended static. I'll copy lines 20 to 25, and going back to the child class, I'll paste that at the end of the class. I'll change base class to child in the printed statement. The mandatory static method is a private static method on the base class, which means I can't call it from this subclass or any class for that matter, so I'll comment out the last statement that invokes it. Okay, so what am I really doing here? I've created a static method with the same signature of a static method on the base class. If you guessed overriding, you'd be in good company, but this is really something else. This is called hiding a method. First, you might have noticed that static methods won't show up in IntelliJ's override method pop-up. The behaviour of a hidden static method is different than the behaviour you might expect when overriding a method. I'll run this, and then I want to compare the first 3 segments of output with the last 3. First, you can see in the second and third segments the text, child, extra stuff here. This tells me the overridden method, the method on child, was executed for both of my child class instances, so the one I called child and the one I called child referred to as base. It doesn't matter what the reference type of the variable is. In other words, child referred to as base, a base class variable, exhibited the same behaviour as child, a child class variable. Compare that to the results of the static method being called on the same 3 instances. Only the output from the last call is different. This is the output of the child instance assigned to a child variable. Only this variable executed the static method declared on child. Why didn't the other child instance variable call that method declared on the child class? Let me demonstrate what's going on using a couple of slides. On this slide I have a base class with one static method called doClass method. I also have one instance method called doObject method. The child class has its own copies of these methods with the same signatures. The child class hides the base class's static method, doClass method. The child overrides the base class's instance method, doObject method. On this slide I'm showing 3 declarations. X is declared as a base class and refers to an instance of a base class. Y is declared as a base class and is referring to an instance of a child class. In this case, base class is the reference type and child is the instance or runtime type. Z is declared as a child and is referring to an instance of a child class. When you execute a static method on an instance, the reference type determines which method is called the one on base class or the one on child. What this means is, even though Y is really a child instance, it doesn't matter for static methods. Static methods are based on the reference, so in this example, X and Y would both execute the static method declared on base class. Instance methods are called based on the runtime type of the instance and not the declared type. This means that Y and Z execute the doObject method on child because they're both instances of the child class. Best practice recommends always using the type reference when executing a static method. If you're hiding a static method on a parent class, make sure you understand what the implications are for doing this. If you stick to using a qualifier, the type reference, to execute the specific static method, you'll avoid the confusion shown on the previous slide. Okay, so now I want to go back to my code. Even though IntelliJ really wants me to change this code, I'll leave it the way it is. The message that I get is static member is accessed via instance reference, and this behaviour, as I just mentioned, isn't recommended. How should I call this code? Well, I can simply use the class types. I'll output another dashed line first. I'll simply call the recommended static method on the base class. I'll also do the same with that method on child class. And running that now, you can see each method was called on the qualifying type, with a lot less confusion this time. You can also make a static method final. Let's do this on the base class to the recommended static method. Remember, this is the method that the child class is hiding. I'll include the final keyword on the declaration of that method on base class. Now I'll go back to the child class, and just like when I made an instance method final, I get an error on this static method. Making the static method final on the base class means subclasses can't hide that method. If I look at that error on the child class, it says I can't override this method. Why doesn't it say hide? Well, IntelliJ doesn't really know if I'm trying to override or hide this method. If I remove the static keyword, I get the exact same message, but for a completely different reason. This is because I can't create a method on a subclass, an instance method, when the parent's method is static. Let me revert that change so that this method is static again, and I'll go back to base class. IntelliJ is highlighting the final keyword and gives me a pretty uninformative message, static method declared final. This is not a compiler error, just a warning, and in fact there could be valid reasons for making a static method final sometimes, preventing subclasses from creating their own versions. If you do see this warning though, use it as a reminder to think about other ways to design your classes. For example, maybe making the whole class final is a better option, and I'll be covering final classes later in this section. For now, I'll remove the final keyword so that my child class can hide this method. Next, I want to revisit final variables. I discussed these a little bit when I talked about using final or effectively final variables in Lambda expressions. I'll start with declaring a final local variable in a block of code. To demonstrate this, I'll create a new method on the main class, private static void doxyz. It'll have two parameters, a string I'll call x and an int I'll call y. I'll use the final keyword before my local variable declaration, so final string c, and I'll assign x plus y to that. And I'll print out c. I'll call this from the main method. I'll set up a local variable x argument, setting that to the text, "This is all I've got to say about section." I'll pass that variable and the integer 16 to the doxyz method. Okay, so running this code now. There's not really any surprises there. It prints, "This is all I've got to say about section 16. This code would work the same whether I declared this variable final or not, and that's because the local variable c is effectively final. That just means I'm not assigning a different value to c after the initial assignment. What happens if I add code to assign c to x, for example, as the last statement in this method? You can see this is a problem and I get the error, "Cannot assign a value to final variable c." I'll undo that last change, removing that statement. You might be wondering why you'd want to use the final keyword when the compiler can figure out that it's effectively final. Well, maybe you plan to use the variable in Lambda expressions. By specifying final, you're informing future developers that this variable needs to remain unchanged. In addition to local variables, I can also make method parameters final as well. Let me do that next. Now I'm going to assign a new value to the variable x. I'll assign c to x here. Again, I can't do this if the method parameter is declared as final. I'll remove the final keyword from the method parameter. The truth is, declaring immutable type parameters final, like I just did here, isn't going to buy much. Let me show you why. I'll print out the value of the x argument variable after the call to this method. Okay, so if I run this now, you can see that the value in x argument didn't change. Its value is the same before and after the method call. In the method, I reassigned the value of the method argument x, but it had no effect outside of this method. This reference x will go out of scope when the method ends. Let's see what happens if I do something similar with a mutable object. I've shown you this before, but let me set this up. First, I'll add a parameter to the doxyz method, a string builder I'll call z. I'll add a statement at the end of this method that appends y, the integer, to the string builder argument. In the main method, I'll set up a string builder calling it z argument, initializing that to the text, only saying this section. I'll pass z argument to my method. I'll then print the value after the method. If I run this now, the output says that after method, z argument says only saying this, section 16. Before the method it did not include 16. This means the method had a side effect on my string builder variable. After the method finishes execution, my Z argument is different. What would happen if I made that third parameter final? Let me do that. I'll put final before the string builder type. I don't have any compiler errors. Maybe you expected to see one on that last statement in this method. Let's run this code. And you can see nothing's changed. I get the exact same result. There are still side effects and my Z argument value was changed. What good is final then when it's used with a method parameter? First, I'll comment out that last line. Instead of using the append method on the Z argument, I'll reassign it to a new string builder instance with different text. Now I've got a compiler error. Like before, I can't assign a new variable, meaning I can't reassign it to the method parameter Z. I'll comment out that last line, and I'll uncomment the line above that, leaving this method with side effects. Using final with a method parameter isn't going to change whether a method has side effects or not. It will simply produce a compiler error if you try to reassign a method parameter's value. This is an important distinction. It's important to understand that when you use final, it doesn't mean the variable is immutable at that point. It means you can't assign or reassign a new instance or variable or expression to it after the initialization. If you use final for a local variable in a code block, you can only initialize it fully or assign it a value just once. Any other additional assignments will result in a compiler error. If you use final for method parameters, this means you cannot assign any values to the method parameters in the code. Remember that method arguments get initialized implicitly when the method is invoked. I'm going to bring this video to a close before it gets any longer. I'll cover final fields and final classes when I cover topics more specific to designing immutable classes. In the next video, I'll be talking about why change isn't always a good thing. I'll see you in that next video.